So I work for an organization called IPUT Real Estate. Just listening to some of the previous speakers there, our organization is a lot smaller and our portfolio is a lot smaller, and the size of our buildings are a lot smaller than some of the examples that you've given previously, but still very relevant in any case. So that's just a little bit about our organization. We're the largest owner of office and logistics assets in Dublin. Property portfolio of 5.2 million square feet with the value of just shy of 3 billion in the current market. The website there at the bottom refers. So the project in focus is just on your screen there. Click on Marty. Yeah. Okay. So this building in the image here is called the Exchange. It's located in the International Financial Services Centre in Dublin City Centre in the Central Business District. And you can see there it's 6 stories over basement. It's 110,000 square feet of lettable area, 7 office occupiers, and 2 small retailers. So that was a 2014 design, 2015 planning process, 2016 and 17 construction phase. It was completed in late 2017. And so you can see it's very modern looking exterior. The floor plates are designed with minimal restriction for ease of use to maximize the space, the light, etc. And there's a LEED Gold accreditation in the building, which obviously is a design accreditation and needs to be maintained in operation also. So that's the project in focus for the purposes of this presentation. We're happy to be a client of Invicara, and much more than a client, a partner, in fact, to try and develop systems in our organization and to help Invicara with their product development also. So Marty's going to speak a little bit more about the process, and then I'll jump back in and explain a little bit more of the specifics.
So just to level set a little bit, I think there's obviously a lot of great conversations at the conference today about digital twins. But I still think there's a lot of different opinions about what a digital twin is. But maybe not a lot of consensus, right? Because there's so many use cases you can use for digital twins and so many things that you can do. But the standard definition that you often hear is pretty vague, and it kind of goes something like this. A digital twin is a virtual representation of a physical asset. Okay, great. But what exactly does that mean? And where does that take you? Where can you go with that? So one of the things that we've seen is this kind of definition of what a twin is kind of leads people to focus on visuals and geometry. And the visualization is incredibly powerful. So that's not wrong, but it's not entirely helpful. What we think, or what we found at Invicara, our approach is to make data very central to the digital twin. So for us, when we think about digital twins, we think about data, and data is the key. So when you're talking about data, I think there's several things that you can think about. In our view, the digital twin has to start with an ontology. And in layman's terms, an ontology is really a framework that describes the world that you want to twin. People have been using digital twins in manufacturing for years. Now we're starting to use them in buildings and to great effect. But the ontology is going to describe the things that you care about in your world, whether it's a building or a smart city, a piece of infrastructure, a plant, what have you. And it's going to also describe how those things are related to each other, right? How do they interact? So in a building, maybe assets are located in spaces, right? Maybe you have an example like this where you have HVAC equipment that are linked together in systems, and an air handler serves a VAV box, which then serves a space, right? So those relationships. And then lastly, the ontology is going to tell us what the data is we care about, right? And all of this is driven by the use cases, right? In our view, we try not to be prescriptive, right? We've built a very flexible and framework to allow people to capture the entities, the relationships, and the data that they need. Then that data is expressed as a knowledge graph. And again, in layman's terms, a knowledge graph is sort of a map of the world, if you will. So it's taking that ontology as a framework and saying, okay, we care about assets, we care about spaces, we care about systems, we care about files. and actually capturing that data for a specific asset, for a specific building. So in the example of our HVAC system, the AHU3 is linked to VAV4, and it has an O&M manual, and it has this metadata, and it's connected to the BMS, right? So this kind of framework is really where we go to. And going back to the thought about visuals, the visuals can be anything, right? It could be a 3D BIM model, and that's what you'll see in the case of Richard's building, the Exchange building. It could be a GIS model. It could be 2D plans, or in fact, nothing at all. We have functioning digital twins that are just data and doing some really wonderful things for people. So that's really it in summing up. And Richard, I'll hand it back to you to talk about the journey from getting to start to finish with Exchange.
So Marty's explained the theory behind how the project is put together. So this is just some sort of a summary of how we actually achieved it on the ground, bearing in mind that some of the people who were working on the project were not very au fait or very familiar with the process from the start, so it needed to be simplified for all users, all members of the project team to be able to participate. So I guess the starting point really was to begin assembling the AOR, the Asset Information Register, and we've heard how this process has been done on some of your previous projects, so you'll all be familiar with how the process works. But just to give a summary of how we approached it. So we began with the AOR, and then we classified and identified the asset information, essentially just to give them some order. Then that information was validated using one of the Invicara tools, Bms Assure, and that essentially gave us a version of our digital twin at that point in time. Now that journey was challenging because the twinning of the building was done retrospectively. It wasn't completed as part of the construction phase, the design or construction phase. So that added a layer of complexity and challenge based on the information that we had post-construction. From that point, we arrived with what we call the Exchange twin, which was specific to this particular project. So we had the O&M files, we had the documents, we had the navigator or the 3D model, we had some extended data, and then we also introduced an interface with the BMS via gateway. So that essentially gave us our Exchange twin at a point in time. So that twin is evolving all the time. We're developing new features. The twin itself acts as a functioning tool for building management, for maintenance, for facilities, in terms of a single source of information for all relevant building information. The dynamic element of the twin is surrounding the building health dashboard and the energy monitoring. And I guess that's the stage of the process that we're at the moment, because it's an ever-evolving project. We're not yet complete, like some of the projects you've heard from earlier on. So we're currently in the process of developing a building health dashboard, which essentially includes a set of rules and parameters that the primary plant is designed to work towards and to measure that against current performance. And the other element is the energy management analytics, just to understand what energy we're consuming and where we're consuming that energy. Okay, so this is just a screenshot from the twin. So if you can make out the image on the right there, you can see it's an overhead shot of a plant room. In red, you can see a set of twin gas boilers. To the right of that, a pair of pressurization vessels and an air and dirt separator. So just bear in mind that this project was designed in 2014 before the electrification of heating or heat pump technology. So unfortunately, we do have a gas boiler there, but in line with our own net zero 2030 plans, all of our future developments, or our current and future developments, are all fully electrification of heating, with some retrofit projects taking place for some of our older buildings. So you'll see in that image there where we have extended data for that particular piece of plant highlighted in the blue color. So the principle of the screen you're looking at is basically select the asset, and the information comes up on the left-hand side. Not only do we have the O&M files and the asset information, we have some extended commissioning data for that particular piece of plant also, which you can see on the left. So that's an example of how that applies to that particular boiler. that particular asset, one of hundreds in the buildings in the building.
If I could pile on a little bit there. So a lot of this information came from the BIM model and the process that Richard described previously, right? But the design data and some of the other data sets that you see here came from very different places. And it all works together ultimately to support that connectivity to the BMS, because we can leverage some of the design data and some of the specification data about certain products as inputs into rules, dynamic input into rules for monitoring building health and building performance.
Okay, so that performance and that building health that Marty just referred to there is summarized in the dashboard that you're looking at on the screen there. So essentially what we did was we identified the key primary pieces of plant, which to this point were being monitored manually via BMS. So we've identified a couple of key performance indicators and key metrics that we were looking to identify. So you can see that's on the screen here. We've broken systems down to heating, cooling, domestic hot water, and primary ventilation, and essentially applied a traffic light system whereby green is healthy, yellow possibly falling outside a parameter, and red is outside of the parameters. So those parameters are parameters that we have decided based on expected performance of the system. We've applied the set of rules that Marty referred to earlier on. So the rule in the case of a boiler may identify when a boiler is enabled, it should reach a particular temperature within a particular period of time. If it falls outside of those parameters, it raises an orange flag, and then it may go on then to identify a red flag and send out an external alert. So we're in full control of the rules and the parameters based on our expectation. Back to the very first slide, when I was introducing IPUT as an organization, we put a lot of emphasis on quality and reliability because a lot of our buildings are multi-tenanted, multi-let, so we manage them. We don't just own and lease them to a single occupier who manage the building for themselves. In lots of cases, we manage multi-occupied buildings, so we're responsible for managing and maintaining and the performance of the systems. Okay, so this single slide basically summarizes it's a slide at a point in time whereby it's summarizing electricity consumption over a 5-month period. You can see in blue it's summarizing weekday performance, and in orange it's summarizing weekend performance. On the bottom left, you can see whereby it's summarizing by day of month in the line graph. And on the right-hand side, bottom right graph, it's indicating the consumption by hour of day at 30-minute intervals. That information can be sliced and diced, depending on how you'd like to see it, based on day of week, month of year, real time, for gas, for electricity. So that's just a point in time.
Right.
Okay,
and I think I would add here just real quickly, looking at this energy data, we're also able to correlate it with the building performance data, right? So we've got the information from the BMS about the operation of the equipment, what's happening. We've got all of the analytics rules for those pieces of equipment. And then we can start to correlate that equipment performance data with actual energy consumption. And I think there's still some things we'd like to do in terms of the granularity of the submetering, and we're looking into that. But I think we're going to get some really insightful analytics when we can say, okay, chiller one, here's the operating characteristics of chiller one or boiler one or what have you. And then let's compare that to the energy consumption and the energy output. It's going to be a very powerful tool.
So just to wrap up then, just so some lessons learned. In this particular instance, it was a retrospective project, so it is more challenging than when it's prescribed from the design and build phase. It certainly can be done once the asset information is available. And working with an organization who've done it before, obviously, and can set a system. Decide on the naming conventions and use of abbreviations. I think that's important. So pieces of equipment such as pumps, air handling units, chillers, heat pumps, boilers, they can be known as, they can be different names can be used by different people. It's important to fix a naming convention, I think, from the beginning. So for example, abbreviations such as AHU, do you use the abbreviation or do you use the full term air handling unit? There are just some decisions that is good to decide from the beginning. a structured approach from the beginning is a good idea. So consider the system by system, heating, cooling, life safety, mechanical, electrical, and then the next point then is the brainstorming bit. So using those systems, brainstorm the system, brainstorm the building to identify all the assets that you're looking to include in the twin, and the interdependency and interrelationship between all of those. Where BIM forms part of a project or new development from the beginning, it's important that there's good discipline by the design and build team to make sure that the twin is kept up to date throughout the build, so that you don't end up with a twin that is based on the design, but more a twin that's based on the as-built environment, which is obviously the real life environment and the situation or the status that you're looking to track. And then finally, regarding the Bms integration, which is a particularly interesting part of the project, was to ensure that the points on the BMS that you think are available to you are actually available to be integrated into the twin. So we had some challenges in that regard, and we overcame them. But for somebody coming at a project from the beginning, just ensure that those points are actually available to you to the extent that you think that they are.
To sum up, when you're looking at building a team around a digital twin, you're going to want people with that domain expertise and that sort of on the ground knowledge of the properties. That's a very helpful thing. And then, we're bringing together domains of information that have been typically siloed, right? So things like joining the BMS with BIM, with GIS, so bringing all of those domains together is definitely a team effort. And we've been lucky to have someone like Richard to work with in that regard for exchange.
Just to recap my understanding, this is a commercial facility building occupied by multiple tenants. Is that correct?
Correct.
Okay, and I don't know the relationship between Invicara and IPUT. So are you the team that look after the facilities management of the building?
No, Invicara, we're a technology provider. So we provide the TwinIt digital twin platform that Richard has been using to create these solutions for exchange.
Okay, so the question that I have is, I like your dashboard that shows all the data that you could generate from the building regarding the energy consumption. Do you use that data to develop your commercial model or the charging model back to your tenant? And do you do the sub-metering of actual energy consumption by tenant using that data, or do you actually have individual meters for each part of the building occupied by each tenant?
Okay, good question. So we do have the ability to break down the energy consumption tenant by tenant, and to the extent that we have retail occupiers and office occupiers occupying different sizes of spaces for different purposes. However, the lease model that we currently apply in this building is based on the floor area for recharge of energy consumption, not actual consumption based on a tenant by tenant arrangement. And that's just the lease model that's applied to this building. But I certainly see an opportunity in the future to incentivize occupiers that they are recharge energy consumption for the building based on their usage, which basically gives the organizations a carrot to reduce their energy consumption as much as possible, rather than contributing to the bill for building based on a poor energy consumer in the building when one occupier might be outperforming. So in this instance, no is the answer to the question, but I do see the potential there for that.